Okay, so last class we didn't finish the problem s of t equals to sine pi t over 2. We were doing the topic of rates of change, and I told you to finish that problem, but I think that that might not be the case for everyone. So today I want to finish that problem with you guys. Okay, so first thing that we did, we found the velocity, right? So the first question was find the velocity at time t, and we just need to take the derivative of this function. Everything is nice and easy, right? So for the second problem, or sub-problem, it was to find velocity at time 1 second, right? So we just plug in 1 into this t, right? And we find that we have cosine equals to 0, so the whole thing will be 0 in this case. Then the third problem was to find when the particle is at rest, meaning that we need to find when the velocity is 0, right? So we need to just find that time, right? So we would have our expression equals to 0. Then we can divide both sides by pi over 2, right? So that we can get rid of this pi over 2 on the left side. And we have just simply cosine of pi over 2t equals to 0. So now we know that cosine equals to 0 at um, every half a pi, right? So we have pi over 2t equals to pi over 2 plus m pi, right? So this is when cosine is equal to 0. Now we want to get rid of this pi over 2, so we multiply by the reciprocal of pi over 2 from on both sides. And we see that these 2's are canceling, pi's are canceling, here as well pi cancel, 2 cancel, and we have here just 1. And on for n pi, pi will be canceled, and we have just 2n in this case. So we want our n to be greater than or equal to 0, because if it's less than 0, right, which is fine for cosine, but in this case, our time will be negative value, right? If we have n equals to -1, for example, then we would have time equals to -1 second, which doesn't make sense in our case, right? So we would restrict n to be a positive value or 0. Now the next problem was find the particle when the particle is moving in the positive direction, right? So we kind of calculated only for 4 seconds. If you have something like this on exam, you will be restricted, to like how many seconds I want you to count. If it's not given, then just do some like arbitrary number. I think 4 would be more than enough, right? So we could see the pattern from there. And then we also know that when n equals to 0, 1, 2, 3, so any integer, right? Our time will be so 1, 3, 5, 7, 8, 9, right? This is the time when the particle is at rest, right? Every 1 plus 2n, that's when the particle is at rest, meaning that the velocity is 0. So that's where we put our zeros, right? So that means that before the 0 and after the 0, we might have some change, right, in the direction. So it's like in the pendulum, let's say it's going forward, backward, backward. So at this point, they are our pendulum is essentially stops for a split second, right, and then reverses its direction to the other side. So we might have something similar, or we might have some kind of like this type of movement or something like that. So we need to check when we are moving in the positive direction, or if we are, let's say, at the 0, right? If we are standing at the 0, when is the particle is moving away from us, right? Depending how you want to write this setup. So we need just to check. So this is our seconds, right? 1, 3, 5, 7, 9. We need to check what are the signs of the velocity at the time kind of in between, right? So we need to have some test points. For our case, it's good to, to use 0, then 2, 4, 6, 8. These are kind of nice numbers to use. They're integers, so it's easy to calculate the um, velocity at that time. So then we will plug in time 0, right? Where did we plug it? Not here, right? So we would have pi over 2 cosine pi over 2 times 0. In this case, we know that cosine of 0 is positive 1, so we have pi over 2 here, so this is a positive value. So we would have a positive value here. Okay, then we check when time equals to 2. So this is this one, right? So velocity of 2, that's pi over 2 cosine pi over 2 times 2. These 2's are canceled. We have cosine of pi, which is negative 1, and multiplied by pi over 2, that's going to be negative pi over 2, which is a negative value, right? So that's why we have here negative. And the next one, oh, we actually checked the 0, right? Yeah, so let me erase that then. All right. And then we check 4, right? And we found out that we have a positive value. And the same way you're checking 6 and 9, oh, sorry, 8, and then you will see that it will follow the same kind of pattern, right? You will have negative plus, next one will be also negative and then plus, and so on and so forth. So now we want to find when the particle is moving to the in the positive direction. This is the intervals where we have a positive sign for the velocity function. So that's going to be from 0 to 1, right? So that's what we write here. And then from 3 to 5, not including, right? Because at 3 and at 5, the particle is at rest. So we don't have any positive or negative direction at those specific points, right? Or that specific time. So that's why we do not write it as less than or equal to. We just write less than. So it's between 3 and 5. If you want to write it in the interval notation, it's going to be from 0 to 1, union from 3 to 5, union from 7 to 9, union, and so on and so forth until, whatever time restrictions you have. Okay, so this is the way that you write it in the interval notation or as an equality this way. Okay, next question was, let me see. Find the total distance traveled during the first 6 seconds. Okay, so as we said, we are starting at time 0, right? We found out that the position is gonna be 0, right? So S of 0 is 0, because that was a sign, right? Sign of 0, that's gonna be 0. Then we need to check what happens at those points where particle is at rest. And this is exactly when we have our time 1, time 3, time 5, time 7, and 9 seconds. So 9 and 7 we don't need. We need only to check 1, 3, 5, and 6, since 6 is the final kind of point or second that we need to calculate the distance, right? So we calculated what happens at time 0. Now at time 1, we know that velocity is 0, but position, we don't know. So we would plug in 1 into the position function, and we find out that we have sine of 2 over pi, which is 1, right? So here we have position 1. Next one is time 3, right? So S of 3 is 3 pi over 2, which is negative 1, right? So we have a point right here. Then S of 5, that's going to be sine 5 pi over 2, which is the same thing as sine of 2 pi plus pi over 2. And we know that 2 pi, sine of 2 pi, that's 0, right? So we can only look at so when you apply that formula, remember the sine of alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. We will get, so this one would be sine of 2 pi cosine pi over 2 plus sine of pi over 2 cosine 2 pi. And this is gone because that's 0, right? And for this one, sine pi over 2, that's 1, and cosine pi over 2, that's also 1. So we have essentially like that. That's going to be 1 here. All right? Or we can write it as well. I guess cosine of 2 pi. It's going to be 1. Okay, and the last one, we need to check what is the position at 6 seconds, right? So we plug in 6 into our position function. We get 6 pi over 2. We can reduce it by 2. So we have 3 pi, which is 0. So the position here is 0. So now to find the total distance, right, we need to calculate d total equals to d1 plus d2 plus how many d's we have. So we would have here d1, right? So that's from 0 to 1, and then we go back from 1 to -1, so that's going to be our distance 2. And then we again reverse and we go from -1 to +1 until we reach for 5, not for 5 seconds, for I guess 2 more seconds, right? And then from second 5 to second 6, we go back distance of d4. So we need to add all of these distances, right? So we would have d1, d2, d3 plus d4, right? Now, d1, that's the distance from the end to the front, right? So we usually calculate the end point minus the starting point, right? For distance 2, again, end point minus the start point. For distance 3, we have endpoint minus start point. And for distance 4, endpoint to start point, right? So we are calculating this way. Don't forget that we need to put the absolute value signs. So we would have here for distance 1, we have s of 1 minus s of 0, and we just plug in the values. We have s of 1 was 1 minus s of 0 was 0. So for the first one, it's going to be 1. Now for distance 2, we have s of 3 minus s of 1. S of 3 was -1, right? So we plug in -1 minus s of 1 was 1. So that's going to be -2, but in absolute value, we have just 2. And this is all in meters, I believe. Or was it feet? What was that given in? Give me a second. Oh, that was in feet. Okay, now distance 3. So that's s of 5 minus s of 3. So s of 5 was 1, s of 3 was -1, right? So we would write here 1 minus -1. We get 1 plus 1, which is just 2 feet. And s of 6 minus s of 5, remember s of 6 was at 0 and s of 5 was at 1. So we will write here 0 minus 1, we get still 1. Okay, and now we just add all of these values together. We get 1 plus 2 plus 2 plus 1, which is just 6 feet. This is the total distance traveled in 6 seconds. Now, we want to draw a diagram to illustrate the motion of the particle. Essentially, what we did here, that was already the illustration, right? So if you're asked to do that, you can just draw this picture here. Now, next question is to find acceleration a of t, right? And also I want to find what is a1 of t. Sorry, a of 1. So the acceleration after 1 second. So let's go back to see what was our velocity function. So that's this one. Copy. All right. So this is our velocity function. So to find the acceleration function, we need to take the derivative of the velocity function, right? So that's the first derivative of velocity function, or the same thing as second derivative of the position function. So we would have here cosine becomes negative sign, right? So we have pi over 2 with the negative sign, sine of pi t over 2, and now we take the derivative of the argument, which is this one, so we would get pi over 2 here, right? So that's the same thing as saying negative pi squared over 4 sine pi over 2t. Okay, so this is our acceleration. Now, after 1 second, a of 1, we have negative pi, squared over 4 sine of pi over 2 times 1. So sine pi over 2 is 1, so we have negative pi squared over 4. Okay, so this is our acceleration after 1 second. Okay? All right, and now let me see. Right, so now we need to graph the position, velocity, and acceleration function all on one graph for the first 6 seconds. Okay, so let me draw. Okay, so probably 1, 2, 3, 4, 5, 6. That's my t. So let's see, we have 1 here, 2 here, -1 here, -2 here. And let me see. So we would probably need pi over 2. That's going to be approximately somewhere in the middle here. And pi squared over 4 is going to be probably somewhere. Let me see what pi squared over 4, what that is. Pi squared over 4. Well, approximately 2.5. So let's put it somewhere here, just for simplicity, in case if we need that. All right. So the first function that we will be drawing will be position function. I will draw it in black. So let's see what we have. Okay, so what were the positions? Okay, so we have the position s of 0 is 0, s of 1 is 1, s of 3 is -1, s of 5 is 1 again, and s of 6 is 0. So let's see, we have 0, 1, -1. Okay, so at position 0, we have 0, 0, right? And then at position s equals to 1, we have, I forgot, 1. Okay, so that's going to be here. Then s of 3 was -1. So that's a point right here. And s of 5 was 1. S of 6 was 0. And we just connected nicely. As nicely as we can. And we remember that we have also velocity here was 0, right? At these points. Okay. Now, this is our... No, velocity was not here 0. It was here it was 0. Yeah. Okay, so the position was 0 here. Okay, now the velocity would be in orange. Okay. What do we have for velocity? We have velocity of 0 seconds. No, we actually don't have that, right? We have, so velocity of 0, that would be pi over 2. Okay, so let's write that. So that's going to be a point right here. Now, velocity of 2, we have here. Velocity at 1, 3, 5 is 0, right? So we can write here at 1, 3, 5, that's 0 everywhere. This velocity is 0 here. And it makes sense, right? Because we have here a local maxima or minima, right? For the position function, this is where the velocity will be equal to 0. Exactly. So if we draw it on one graph, that's where it is. Okay. And then let's check what happens here and here. Let me see. Do we have anything for 3 and 5? Okay. Velocity of, not 3, at 2, we have negative pi over 2. And for 4, we have positive pi over 2. Okay. So at 2, we have negative pi over 2. So that's a point here. And at 4, we have positive pi over 2. So I'm expecting at 6 seconds, I am expecting to have the same thing since we have the same amplitude. And now just connect the points nicely. And this is your velocity function. Okay. And the last one would be the acceleration function. Let me do it in green. So what we know about the acceleration function, for now we have only a of 1, right? So that's the only point we know so far. It's going to be negative pi squared over 4. So we have a of 1 is negative right here, negative pi squared over 4. Now let's calculate what happens at 0. So we have here, well, it's going to be sine of 0, so that's going to be 0, right? So we would have a point right here. And then we can also calculate a of 2. So we get here negative pi squared over 4 sine pi over 2 times 2. So these are canceled. The whole thing is 0, right? So we would have here again a point right here. And I am expecting to see a of 3 to be here, pi squared over 4. Let's check. So we have negative pi squared over 4 times sine of pi over 2 times 3. So sine 3 pi over 2, that's going to be negative 1. So the answer is indeed positive pi squared over 4. So we see the pattern. It's going like this way, right? So we'll probably see the same here. So we would have 0 at 4, and at 5 we will see the negative pi squared over 4, and again 0 at 6 seconds. And we just connect the points nicely. Okay, something like this. Okay, so this is how you draw all the graphs on one uh, graph, I guess. Okay, so now the last question is, when is the particle speeding up and slowing down? Okay, remember, when we have the velocity and acceleration have the same sign, we are speeding up. When velocity and acceleration have different signs, we are slowing down. So let's look here. From 0 to 1, right? We see that the acceleration is negative and the velocity is positive, right? So in this case, we are slowing down here, right? Because these are different signs. Okay, so we are slow down at from 0 to 1 and speed up. Now, from 1 to 2, again, we see that velocity is negative, acceleration is also negative. So this is when we speed up. So from 1 to 2, union. Next one. From 2 to 3. Oops. From 2 to 3, we have acceleration is positive, velocity is negative. So this is where we slow down, right? So we have from 2 to 3. From 3 to 4, we have both are positive, right? So this is where we speed up, 3 to 4. And from 4 to 5, acceleration is negative, velocity is positive. This is where we slow down, 4 to 5. And from 5 to 6, both are in the negative direction, right? So we are below the t-axis or x-axis right here. So that means that these are both the same signs. So we would have here speeding up from 5 to 6. And this is it for this type of problems. That's how you finish this problem. Now, let me go over a couple of examples for the limit. Do you have any questions on this type of problems? There is a lot to do. So on exam, if I ask you a problem like this, I will not ask you all of these questions, all of this like 6 questions or how many we had? 9 actually, 9 questions. I will not ask you all of them, just some of them. Okay, so don't worry about that too much. Okay, so let me go over some of the limit problems. Limit as x approaches -3 of sine x plus 3 over x squared plus 8x plus 15. Okay, so I want to find the limit. Now, if we plug in -3, we get 0 over 0. Okay, so that's not something that we want to do, right? So we need to do something with this expression. So first of all, let me write the denominator as just 2 factors. Limit as x approaches -3 of sine x plus 3 divided by x plus 3, x plus 5. Okay, so you see that we have this x plus 3 in the denominator and the what's it called? The argument is also x plus 3. We know that there is this rule, limit as x approaches 0 of sine x over x, right? Or we can have like 3x over 3x, like that, or anything else, right? But this is not exactly what we have. We have the x approaches -3. We have here some more involved argument, right? So what if we try to make this expression look like this one? So let me make some u equals to x plus 3, right? So now when I write this expression, I see that I can substitute x plus 3 with u here, and if I solve for x, I can also substitute u here. So let me solve for x. That's gonna be u minus 3, right? So I would write, instead of this x, I would write u minus 3 here, okay? Because I need to change all of the x's with u. But okay, so here we can substitute it with u here and here, but what about the limit? what about where x approaches -3? So let's recalculate what our limit will, what the new variable y would be, sorry, u would be approaching in this case. So it's you cannot write it as limit as u approaches -3 because it's not approaching -3 anymore, because your u is x plus 3, right? So you would need to recalculate what that is approaching. So as x approaches -3, your u will be approaching -3 plus 3, which is 0, okay? Don't forget to change your limits here, the condition where we are approaching. So we would have here a limit as u approaching 0 of sine u over u times u minus 3 plus 5, right? Now, as you can see, this is exactly what we have here, just with another variable. It's u instead of x, right? So this whole expression, that's just 1. And now when we plug in 0 into this u, we get, so let me write that. So we have limit as u approaches 0 of sine u over u times limit u approaches 0 of 1 over u minus 3 plus 5. So this guy is 1, and this one would be 1 over 0 minus 3 plus 5 will be 1 over 2. So this is the answer for this type of questions, okay? For this particular question. So this is how you approach it. Now let's do another one very similar to that. We have limit as x approaches 2 of sine x minus 2 over x squared minus x minus 2. Okay, so if we plug in 2 into expression, we get 0 over 0. That's not what we want. So we will just, first we will deal with the denominator, and then we'll maybe do some substitution if needed. Okay, so we have limit as x approaches 2 of sine x minus 2 over x minus 2, x plus 1, okay? All right, so if you see it right away, you can just, make it 1, right? And just work with this one. Okay, so we would have here, if you don't see it, then do the substitution. If everything is fine, then you can say like, oh, here that's the same expression as here. This one, if we make a substitution, this will be 0. Then everything just goes to 1. So everything is good and beautiful. We just calculate the second, what's it called, factor. But if not, then just do like that. U equals to x minus 2. From here, x equals to u plus 2. And also, as x approaches 2, our u will be approaching 2 minus 2, which is 0. So we will be changing the limits as well, right? So we would have limit as u approaches 0 of sine u over u times u plus 2 plus 1. We get the same thing. This one is 1. And when we plug in 0 here, we have 1 over 2 plus 1, which is 1 over 3. So this is your final answer. Okay? All right. Now, we had a similar question on the board when we had a session on Monday, right? But I noticed that everyone was kind of avoiding that problem and no one gave it the love it deserved. So let me show you how to actually solve it so you don't get scared of that type of problem. So we have limit as x approaches 0 of 1 minus tangent x minus 1 minus sine x over x squared. Okay, so if we plug in 0, we get here 0, 0. We have square root of 1 minus square root of 1, that's 0 over 0, right? So we need to do something with this expression so that it's not 0 over 0, right? So what we need to do is we multiply by the conjugate. Since we have here the square roots, probably it's a good idea to get rid of those square roots. Okay, so we will multiply by 1 minus tangent x plus 1 minus sine x, top and bottom. And we would have here limit as x approaches 0 of 1 minus tangent x minus 1 plus sine x. Why? Because when we have here squared, right? So the square root of square are lifted, and we have here negative that will be also applied for this negative sign. So this is why we have a positive sign here. Don't forget that. If you want, you can just do step by step, right? So, like keep the parentheses and then open the parentheses and get your positive. But if you get here negative, that will be a mistake. Okay. Divided by x squared square root of 1 minus tangent x plus 1 minus sine x, like that. Okay, now this ones get canceled and we have a negative tangent plus sine. So let me first write limit as x approaches 0. Let me first write sine x minus, now I'll write tangent, tangent x, but let me write it as sine over cosine, okay? So I have sine x over cosine x, and then I divide by the same expression on the bottom. I don't do anything with the denominator. Okay, now I want to get rid of this fraction. So what I do, I multiply top and bottom by this cosine, okay? Oops. Right? The whole expression. So I will be multiplying here, here, and also here. Okay. So what I get is limit as x approaches 0 of sine x cosine x minus, now cosine and cosine right here will be canceled, and I have minus sine x, and then my big denominator x squared cosine x. Let me actually separate it into two expressions. So times 1 over 1 minus tangent x plus 1 minus sine x. Because I don't think that there's something that we can do right now with this expression to simplify it, but we can work with this expression, okay? So what we have here is we can factor out sine, right? And we would get limit as x approaches 0 of sine x cosine x minus 1 divided by x squared cosine x times, let me just apply limit for the second expression, and I'll just rewrite that. Okay. Now, what I want to do here is, first of all, we know that as x approaches 0, sine x over x, that would be equal to 1, but we have another x, so we need to kind of like separate it, right? Then we also know that cosine x minus 1 over x as x approaches 0, that would be equal to 0. We also showed that in class the other day. So let me separate this expression into kind of several expressions, maybe 2 or 3. So I would have limit as x approaches 0 of sine x over x. So I'll just split this x squared into x and x. and then times limit as x approaches 0 of cosine minus 1 over the leftover x, and then times 1 over cosine x, or we can apply it there, and then times this whole expression here. Oops, duplicate. All right. Now, we know that this one is equal to 1. This one is equal to 0. Let me write here, limit as x approaches 0. Limit as x approaches 0, it will be 1 over cosine 0, which is just 1, right? Now here, if we plug in 0 into tangent, tangent becomes 0. If we apply x equals to, 0 to sine x, that will be also 0. So what we have here is 1 times 0 times well, that's the whole thing will be 0 then, huh? Yeah. 0 times 1 times here we have 1 over square root of 2, 1 times square root of 1, right? So this is our 0, so the whole thing will be 0 no matter what we have there. So the expression will be 0 in this case. Okay? So not that bad. Okay, now let's get to another example. Oh, let me show you one with the e because we didn't see that much of those examples. Okay, so let's say we have y equals to sine squared e 3 to the power of 3x plus 1. Okay, we know that the derivative of e to the x is just e to the x, right? If we have more kind of complicated expression in this power in the exponent, then we just use the what's it called? The chain rule, right? So to find the derivative, first of all, we see that we have here this square, and this sign would be the base. So first we take the derivative of the shell, and then the derivative of the base, and then our argument in the sign also is kind of like a nested chain rule. So okay, so first we will do sine, 2, the derivative of sine squared would be 2 sine to the first power, right? E to the 3x plus 1. So for now, we don't take the derivative of sine, right? Because we're taking only the derivative of the shell. But now once we did that, we multiply by the derivative of sine now, and we keep the argument untouched. So the derivative of sine is cosine e to the 3x plus 1. Now, once we took the derivative of cosine, we take the derivative, like we multiply by the derivative of the argument, which is e to the power 3x plus 1 would be 3, e to the power of 3x plus 1 as it was, right? By this rule, so by the same thing, and then multiply by the derivative of the what's it called? The exponent, right? So in this case, we have only a polynomial, right? So the derivative of 3x plus 1 would be just 3. So we multiply by 3. Now we make it a bit more kind of simplified. We will take 3 to the front. We have 3 times 2, that's 6. Probably it's a good idea to keep the e also to put it in the front. So e to the power of 3x plus 1, and then just to rewrite sine and cosine. Sine e to the power of 3x plus 1, cosine of e 3x plus 1. Okay, so keep in mind that this and this are arguments. You cannot do any funny stuff like factoring out. e to the 3x plus 1 because this is the same thing as saying that this is alpha, right? So that would be the end of your problem. That's the end. Okay? All right. Now, I mean, again, if you have any questions, feel free to stop me at any time and ask your questions. Otherwise, I will just continue on. So let me do a couple of problems for the implicit differentiation. Okay. So let me do this example. Probably that would be a bit more difficult for now. Sure, let's do this one. So we have x squared over x plus y equals to y squared plus 1. Okay, so again, using the implicit differentiation, we take the derivative of every single term just step by step, right? So at first, you see that on the left side, we have the quotient rule, right? So we need to take the derivative, let me see. So this would be your u. This would be your v, okay? So then we would have u prime v minus u v prime over v squared. Okay, so u prime would be 2x times x plus y minus, now we keep the u as it is, right? So we have x squared now multiplied by the derivative of v. So derivative of v will be, so derivative of x is 1 plus derivative of y is 1 y prime, right? So we would have y prime here. Now divided by square of the denominator, x plus y squared. That's it. Now for the right side, we have here y squared plus 1. So 1 is gone. We have y squared. That's going to be 2y times y prime. 2y times the chain rule y prime. Okay. Now we need to solve this equation for y prime. So we have y prime on one side and on the other side. So probably let's use cross multiplication so that we get rid of this fraction. We have 2x, and along the way we will be just distributing the 2x and x squared. Okay, so we have 2x squared plus 2xy, so that's this one and this one, minus, now this and this is going to be x squared minus x squared y prime equals to, now we have 2y y prime times x plus y squared. Okay, so we did the cross multiplication here. And now let's combine the terms for, let me see. Okay, so let's combine these two. We have x squared plus 2xy minus x squared y prime equals to 2y y prime x plus y squared. Now let's combine the terms with the y prime, and everything else we will put on the other side of the equation. So we would have, let's keep these ones here. So we have x squared plus 2xy equals to 2y y prime x plus y squared plus x squared y prime, right? And now we would have on the right side we have y prime 2y x plus y squared plus x squared, right? And on the left side we still have the same. And y prime is equal to x squared plus 2xy over this whole thing, right? 2y x plus y squared plus x squared. So I don't think that there's anything more that we can do to simplify it, or that will change the expression and makes it more pretty. I think this is a good way, good point to stop this problem. So if you write it this way, that would be more than enough. Okay, now let me do a couple of more problems like this. So let me do this problem exercise. This one is a bit different. Xy plus y cubed equals to 1. I want to find the second derivative at a point where x equals to 0. Okay, so I give you only the x coordinate. Okay, so what you need to do first, we will need to find what the y value is, right? So we need the actual point. So we will plug in 0 into the original expression. We have 0 times y equals to y, sorry, not equals to, plus y cubed equals to 1. So we will have y cubed equals to 1. From here, we know that y should be equal to 1, right? Okay, so our point is 0, comma 1. This is the point of interest. Now, first step, we need to find the question asks us to find the second derivative. So first we need to find the first derivative, right? So we would have xy plus y cubed equals to 1. We need to use the implicit differentiation to find y prime, right? So we would have xy, that's just the product rule. So we have 1 times y plus x times y prime plus y cubed, that's the power rule with the chain rule, right? So we would have 3y squared times y prime equals to, this is the constant, so we would have 0 here. Okay, now let me write it nicer. Y plus xy prime plus 3y squared y prime equals to 0. So from here, I want to find what are the values of y prime at this point 0, 1, right? So we know what x is, we know what y is. We don't know what y prime is, right? So let's find that. We will plug in point 0, 1. So we would have 1 plus 0 times y prime plus 3 times 1 squared times y prime equals to 0. So this is gone. We have 3y prime equals to negative 1, right? So y prime equals to negative 1 over 3. So these are our values that we know so far. So x equals to 0, y equals to 1, y prime equals to negative 1 over 3. So for now, let's just keep it somewhere on the side. We will probably use them further on. Okay, so we found this is the expression, the first derivative, right? So now for the second derivative, we need to take again, we use this expression and just implicitly find the second derivative. Okay, so let me rewrite the expression again. So y plus xy prime plus 3y squared y prime equals to 0. Okay, so when we need to take the second derivative, it's the same thing as doing it first time, right? Just once again. So the derivative of y is 1 times y prime plus x times y prime. That is our regular product rule. So we'll take the derivative of x, which is 1 times y prime plus x times the derivative of y prime, which is y double prime, right? So whenever we take the derivative of the first derivative, that's going to be the second derivative, right? So that's this, and then plus Now here, again, we use the product rule, right? So this is my first, like my u expression. Let me write it. So this is my u, and this is my v. Because you need to treat this y and y prime as two different variables, because this y and y prime, they're different. For example, at x equals to 0, your y is 1, but your y prime is -1/3. So you already know that these are two different variables, right? Don't treat them as just one variable. Okay, so now we need to take the derivative using the product rule. So derivative of u is 6y to the first power times y prime, right? So we need to take also the chain rule of that, times v, which is this y prime, okay? So this whole thing, that's your u prime. This is your v. Now plus, we rewrite the u 3y squared, so that's your u. And now times the derivative of y prime is y double prime. So this is your v prime, okay? And that is equal to, again, 0 as it was. All right, now let's plug in the values that we know to find what is the y prime, y double prime. Okay, so we know that y prime is -1/3 plus 1 times y prime again is -1/3 plus x is 0 times y double prime. We don't know that. We will write that as an unknown. Let me put that a bit down here. Now plus 6 times y is equal to 1 times y prime is equal to -1/3 times another y prime, it's -1/3 plus, or we can write it actually as it's just squared, right? Plus 3 times y squared, that's 1 squared, times y double prime equals to 0. Okay, so this one is gone. And we have here -1/3 minus 1/3 plus, no, yeah, plus. So this is going to be +1/9, right? So that's going to be, so plus 6/9 for now, plus 3y double prime equals to 0. Okay, so we have here -2/3 plus this one is 2/3 plus 3y cubed, sorry, double prime equals to 0. So these are gone. We have 3y double prime equals to 0. So y double prime equals to 0. And this is what we needed to find. So we found that second derivative of that function of this function xy plus y cubed equals to 1 at x equals to 0, the second derivative is equal to 0. So this is the end of the problem, okay? So this is how you would write that one. Now, let me probably do a couple of more, maybe one more. Okay, yeah, let's do this one. And then I can let you go. Okay, so square root of x plus square root of y equals to 1. Okay, so remember, we can do this problem explicitly, right? Or we can do that implicitly. So if we want to do it implicitly, if you're asked to do it implicitly, then again, you'll just need to take the derivative of each term. So let me rewrite this in more, I guess, comfortable way, right? So that we can take the power rule easier. So we would have the derivative of x to the power of 1/2. That's going to be 1/2 x to the power of -1/2 plus the derivative of square root of y is just 1 over 2 y negative 1 over 2 times y prime equals to 0, right? So in this case, it's not that bad. So now we can multiply the whole expression by 2, right? And we can get rid of this 2. We have just x to the power of negative 1 over 2 plus y to the power of negative 1 over 2 y prime equals to 0. Now, what I want to do is just isolate y prime on one side of the equation. So we have y to the power of negative 1 over 2 y prime equals to negative x to the power of negative 1 over 2. Or we can also write it right away as 1 over square root of x, right? And if we want to isolate y prime, we would need to multiply by y to the power of positive 1 over 2, right? Both sides. So this will be canceled. We have y prime equals to y to the power of 1 over 2. That's the same thing as square root of y, right? Divided by square root of x with a negative sign. And now we know that we can, this y prime, that's exactly the same as this one. So we can say that y square root of y is 1 minus square root of x, right? So we can plug it into our expression for y prime right here. So we would have y prime equals to negative square root of, well, actually, yeah, just as it is, right? So we have 1 minus square root of x over square root of x. Okay, and now if you want, you can write it as negative 1 over square root of x plus 1, or leave it like this. So it's your call, whatever you want to write it as. Okay, and I think that is it for this session. If you have any questions, please ask. If no, then I'll see you on Monday.
Are you going to post the recording, Professor?
I will post the recording, yes.
Thank you.
Mhm.